mercury sensor. If you move it, it should beep. There you go. It is insanely bright. This is one of the projects I made, I don't know, for the Makers Faire in Adelaide 2015. I just needed to gobble up a little alarm device. It's a bit of fun. I mean, it was a Makers Faire and I was demoing my own microcontroller board. So what better to create a little alarm system made of the very same components. Now, this is a very long time ago. I used a Adafruit microcontroller here, which I wouldn't do normally. I would just build it myself. But back in the day, this was just cobbled together really quickly. And I just found this recently, and I just want to have a look because I don't fully remember what it does. But I think what I wanted to do is protect one of my PCBs and have a little bit of fun with all the components I found. So you can see here a very old mercury switch that I salvaged from some device. Can't even remember where it came from. And by the looks of it, it is a sonar and motion detection alarm. So this could be a good opportunity to actually reverse engineer and talk about how to turn this into a schematic and how to write code for this. Okay, now let's have a look at the diagram. So the main part consists of an Arduino. Any Arduino board will do. And I've just selected random outputs. And that was just more of a convenience, like what was connected to where. And the main part is obviously the Luxion RGB LED, which I have had connected to 3 MOSFETs to drive it, and no current limiting, just very simple 2 watts resistors to limit the current. So it was very hastily put together, but let's go through the diagrams anyways. We have a few parts. We have the mercury switch, we have the sonar, a piezo buzzer. It's a speaker actually. Well, it's actually a buzzer, it's not a speaker. It produces its own tone when you power it. An LED and a push button, and that's just about it. Now what we can see here is I connected the switch to low, so that means in open it's high, so it's active low. So that means that within the microcontroller we have to use a resistor pull-up so it stays on high all the time. You don't want the signal to float, and then when you press the button it will detect the low. So it's inverted logic in software, but it's usually easier. The reason why the older microcontrollers didn't have a feature to pull it low, only to pull it up. So I always had to use active low unless I put a resistor on the board myself, but I could just save an extra component by choosing active low. So you just have to revert the logic in the code. It's not a big deal. An LED, a buzzer, the very much used Sonar, the HCSR04, very well known. It's basically, it's got a speaker and a microphone, and 2 pins, well 4 pins, 2 for power and an echo and a trigger. And the echo is actually input and the trigger is actually the output. So the output controls the speaker and the input is the mic. And then the mercury switch is just a normal switch, very much like a push button. And again, this is connected to ground, so it's active low. That means when it's pushed, when it's activated, it's low, and if it's not used, it's high. So here you would have an internal pull-up as well, but I just didn't have enough room to draw it, hence the line above input. And let's go to the most interesting bit, the Luxion LED. Now this particular type is a 3 watt RGB LED, and it's a common anode, which means all the anodes are connected together to +5 volts. And these are 3 watts, so they can draw a lot of current. Roughly, you want to push around 350 milliamps through each LED. That means you have to have a very beefy transistor. So the way it works is when this MOSFET switches on, the current flows through the anode, through the resistor, through ground, and it lights up the LED. And the MOSFETs are actually controlled by the Arduino, and they are pulled low actively. So when they're low, they're off. They're open switches, as it were. And when you go high, it will basically switch on the switch, the MOSFET, and the current is allowed to flow and switches on the LED. Now this is a symbol of an N-channel MOSFET. It has a intrinsic diode built in, so I always include that into the schematics, but you don't have to worry about it really. The only thing that's important, this is a really general purpose MOSFET, way overkill. It's an IRLB 8721 for the people playing at home if you want to build this. And I've drawn the layout, so this is the front, gate, drain and source. Gate, drain and source. Now I just have a 10K pull down resistor. This is a normal resistor, metal film resistor, just to make sure that it's always off. And when you put a high signal on it, the reason why I put 10K on it is there's a little current flowing, but not a lot. So it switches on the MOSFET. These are special resistors, as you can see. They are beefier. These are very old carbon 5% precision resistors, I think, 2 watts. So you have to do a little bit of a calculation. Now what I did here is I wanted 350 milliamps approximately, and you need to know the forward voltage of each of these LEDs, and then you can calculate the resistance. So for these two it's 3R9, which is a notation for 3.9 ohm, and this is 6R8, which is 6.8 ohm. And once you've calculated the resistor, I'm not going into too much details, you need to know the wattage. Now that is important. So the wattage is current squared times the resistor. And for 3R9, and you know the forward current, that is approximately 480 milliwatts and 840 milliwatts. So 2 watts is more than enough. You want to always double the value. It's good engineering, double the value so you don't get too hot. Now this is not a great way of limiting current because all this power is just wasted. It just turns into heat. But for this circuit it's good enough. So that's basically how this circuit works. Let's have a look and see if it still works. I have no idea. Let's power it up. And let's connect 5 volts to this puppy. And ground here. And switch on my trusty power supply and switch it on. Now here you can see that the old Arduinos had bootloaders. Well, they all had bootloaders, so there's a little delay in powering it up. I don't like it. I try to program them, or I tend to program them without a bootloader, so they instantly start the code, and that also means you have a little bit more space to put in code. Okay, now let's check the mercury sensor. If I recall, if you move it, it should beep. There you go. Hope you guys can see that. You may not see it on camera very well, but it is insanely bright. Right, the Sonar doesn't do anything, but I recall there was an arm switch. Oh. So let's press the arm switch. Got some blinking action, and it appears to be armed. So the idea was to protect a PCB at a certain distance, so it won't do anything if I move close. If I move far away, but if I adjust the right distance, and you just can't see it, let's move this away a little bit further. If I'm at the right distance, it will trigger. However, if I'm very close, nothing will happen. If I'm further away, you can't see my hand now, but nothing will trigger. So it will only trigger in this area here. So that's the idea. You create a kind of a security bubble. Now, this software has been written a long time ago. So it starts up with defining the pin connections, as we could see in the drawing. So we have the Sonar connection, the pins for RGB, and the buzzer, the alarm buzzer, the arm button, and the mercury switch. And here we have some variables we'll use in the program. Now, I tend not to use the Arduino language like long and int. That's not very precise. Like a lot of the examples you will see int for an integer, but an int is actually 2 bytes, and if you only have a value that is 20, that is just wasting space. So I like to use this notation, and let me explain what it is. It's very simple to read. It's a unsigned int. That means it's only a positive number. If I omit the u, then it's a signed int, and that means I can have negative and positive numbers, but you limit your range. So in case of a unsigned 8-bit type, I can go from 0 to 255. If I omit the U, it will be a signed int, and then it will be half of it, like minus 127 to plus 128. So I'm using unsigned, 8-bit type, so it's very easy to read. So this is just a byte, and I'm using low value, so that's fine. For other variables where I need more, I use 4 bytes, so it's a 32-bit type, so it's very easy to read. And here I need 4000, so that will easily fit in 2 bytes, so I use a 16-bit type. So yeah, it's just, I like it better, it's just easier to read than using int everywhere. Like you see it a lot in for loops. They go like 0 to 10 and then use an int. That's just a waste, that's 2 bytes, so I don't do that. Now let's have a look at the actual code. What we have here is a couple of functions. So let's omit the functions first. Let's go to the setup. So in the setup, we're setting the pin modes either to input and output. Now it's important to remember in Arduino, input is the default setting, so you don't need to declare it. It's optional, but I like to do it. It just makes it a bit easier to read. So the echo pin is an input, trigger pin is an output, and LED pin, obviously that's an output. The RGB, 3 LEDs, so that's 3 outputs. The buzzer, also an output. And the arm, which is the button, that's an input. And here you can see the special notation to turn on the internal pull-up resistor by just using underscore pull-up instead of just input. So this enables the internal pull-up resistor. And this is a attach interrupt, so it will run this routine on this condition, and it will check out this pin. So you can say pin 8, if this condition happens, then run this program. Now in this case, there's a few options. Falling, that's when the signal goes from high to low. Remember, my switch is active low, that's what I want. You can have low to high, you can have change, which means any change, and low. So for my case, because it's active low, I want to know when it's going from high to low, falling. Yeah, so that's it. And in the setup, we're running 3 programs that really aren't very useful. So let's have a look at the first program that runs. System online. Okay, let's go to System online. And all it does, it blinks the green RGB part just 4 times. High, low, high, low, high, low. I don't know why you can put that in. I think I put it in to let you know that the bootloader is finished and the program is about to start, because I told you bootloader takes a little bit of time. So this gives you an idea, okay, the Arduino is ready. And then it goes into an infinite loop. So while this is true, keep running. So it's active low, so this thing will run forever and ever. It will never progress up until we press the arm button. And when we press the arm button, we get the arming sequence, which is another totally unnecessary routine, but I put it in there for fun. And all it does, by the looks of it, it blinks the blue arming LED a couple of times. And after that, it turns it on and off for 2 seconds to let you know the arming has commenced. And now the main program starts. And there's only one routine in it. Get distance and then wait 50 milliseconds, and this happens over and over. So this will be the Sonar routine. So let's have a look at that. Get distance. So again, all we do is, I'm not going through all the code, but you can pause it and have a look. But it will send out a pulse, and then it will calculate the time it takes the pulse to reflect, and from there on it has a time. And if the distance is less if less than the maximum range and larger than the minimum range, so if it's in that particular bubble, then it will run this little program, and all it does is flash the red and blue LED and turn it into a police flash. And what a police flash is usually looks like, it's 4 flashes red, 4 flashes blue, and a delay in between. And you do that a couple of times. So that's all this does. It flashes it once. So 4 red, 4 blue, and little delay. And then every time it detects an object within that bubble, it will keep running this routine. So it's pretty straightforward. It's nothing complicated. I built this the night before I went to the Makers Faire, so I thought like, oh, that would be nice, and quickly wrote this code. And that's it. I hope you like it, and maybe it will inspire you to make similar projects. See you next time.